On the red plains of Mars, NASA's Perseverance rover is bottling up secrets. It's a lonely explorer, far from home, rolling across a landscape that hasn't changed for billions of years. Every day, it faces dust storms, freezing nights, and the endless silence of a world untouched by life as we know it. But this isn't just another robot taking pictures. It's on a mission to collect Martian dust, soil, and rock, carefully scooping up pieces of Mars and sealing them in special tubes. Each sample is chosen with care, representing a different chapter in the planet's mysterious history. These tubes are like messages in a bottle, waiting patiently on the Martian surface. They're silent time capsules, holding the secrets of a planet that may once have been alive. Each one could hold a clue to the age-old question, are we alone in the universe? Inside there might be chemical fingerprints, ancient minerals, or even the fossilized remains of tiny Martian life forms. For centuries, humans have gazed up at the night sky, wondering if there's anyone else out there. From philosophers to scientists, the question of life beyond Earth has inspired stories, dreams, and entire fields of science. Now for the first time, we're taking real, concrete steps to find out. Perseverance is more than a machine. It's a symbol of our curiosity and our drive to explore the unknown. Perseverance is our detective, gathering evidence from a world that once had rivers, lakes, and maybe even an ocean. It searches ancient riverbeds and lakebeds, places where water once flowed and life might have thrived. The samples could contain fossilized remains of ancient Martian microbes, or perhaps just the chemical hints that life was once possible. If we find even the faintest sign, it would forever change our understanding of life in the universe. The Mars Sample Return mission aims to bring these pristine samples back to Earth for the first time ever. It's a daring plan. Rockets will launch from Mars, carrying these precious tubes across millions of kilometers of space. This is more than a search for aliens, it's about understanding our own origins and our place in the cosmos. By studying Mars, we learn about Earth's past, and maybe even its future. If life started on both Earth and Mars, it could mean life is common in the universe. It would suggest that wherever the right conditions exist, life finds a way. If not, it shows just how rare and precious life here is, a fragile spark in a vast, silent cosmos. Either answer is profound, and both remind us how special our planet truly is. Either way, the journey to bring these samples home is pushing science and engineering to their limits. Teams of scientists and engineers are working together, solving problems no one has ever faced before, all for the chance to answer humanity's oldest questions. The story these rocks tell could be the most important ever discovered, a message in a bottle, sent across space and time, waiting for us to open it and discover what it means to be alive in the universe. The Mars Sample Return mission is a cosmic relay race, with each runner passing the baton across millions of miles. Perseverance is the first runner, collecting and storing Martian samples. It can keep tubes on board or drop them at a sample depot for backup. Next, a sample retrieval lander will arrive, carrying a rocket and 2 helicopters. The helicopters will fetch the tubes and bring them to the lander. A robotic arm loads them into the Mars Ascent Vehicle, the first rocket to launch from another planet. The rocket blasts the samples into Mars orbit. There, the Earth Return Orbiter, built by ESA, will catch the cargo. Then, it's a long journey home to Earth. Perseverance landed in Jezero Crater, a place that has captured the imagination of scientists and space enthusiasts alike. This isn't just any spot on Mars, it's a window into the planet's distant past, chosen with care and purpose. Jezero Crater was selected because it holds ancient secrets, buried beneath layers of Martian dust and rock. Scientists believe this site could reveal clues about whether life ever existed on Mars. Billions of years ago, Jezero wasn't a barren crater. It was a vast lake, filled by a winding river that carved a beautiful delta. This delta, now fossilized, is a time capsule, preserving the story of water on Mars. On Earth, river deltas are some of the best places to find evidence of ancient life. They trap and protect organic matter in layers of sediment, creating a record that can last for eons. The same processes may have happened on Mars. If Martian microbes ever thrived in Jezero's waters, their remains, tiny fossils or chemical traces, could be locked away in these ancient rocks, waiting to be discovered. That's why Perseverance is drilling into mudstones and rocks altered by water. These are the best places to search for biosignatures, evidence that life once existed, even if only as simple microbes. The longer water lingered in Jezero, the more opportunity there was for life to take hold and evolve. Each layer of sediment tells a story about the environment and the passage of time. By collecting a diverse library of rocks and soils, Perseverance is helping us piece together the puzzle of Mars' ancient environment, climate, and habitability. Once these samples are returned to Earth, our most advanced laboratories will analyze them in ways the rover simply can't. We'll use powerful microscopes and chemical tests to search for the faintest hints of life. Scientists will look for organic molecules, fossil-like structures, and subtle patterns in the chemistry of the rocks, signs that could point to ancient Martian life. Even the tiniest chemical fingerprint could be a clue, helping us answer one of humanity's oldest questions. Are we alone in the universe? Jezero Crater is our best shot at finding Martian biosignatures, a true ancient oasis, holding secrets that could change our understanding of life itself. What are scientists hoping to find inside these tubes? Biosignatures, evidence of past or present life. The dream discovery, a microfossil, a fossilized Martian microbe. But biosignatures can also be subtle complex organic molecules or patterns in rock chemistry shaped by life. Perseverance has already detected simple organics, but only Earth's labs can confirm if they're biological. Scientists will look for layered structures, mineral patterns, and chemical fingerprints that hint at life. We might even find something totally unexpected, life with a different chemistry. These samples are a pristine record of Mars's history, ready to reveal its secrets. They'll help us understand Mars's climate, geology, and its potential for life. The final leg is the most dramatic, bringing the samples home. The Earth Return Orbiter will fire its engines, carrying the samples in a shielded entry vehicle. As it nears Earth, it will release the entry vehicle for a high-speed landing in Utah's desert. The vehicle, built for a hard landing, will protect the samples through fiery re-entry and impact. A recovery team will rush to secure it and transport it to a special laboratory. There, scientists will open the tubes in a secure, sterile environment. Robotic arms will handle the material, protecting both Earth and the samples. For the first time, we'll study pristine pieces of another world. Mars sample return is one of the most complex robotic missions ever. Perseverance's drilling and caching system must work flawlessly, millions of miles from home. The new helicopters must autonomously fetch tubes and return them to the lander. The Mars Ascent Vehicle faces the unprecedented challenge of launching from another planet. Every step, landing, retrieval, launch, rendezvous, must be perfectly timed. If any link fails, the samples could be lost forever. The mission's cost is high, sparking debate and constant redesigns to balance ambition and budget. NASA and ESA are pushing technology to its limits, determined to succeed. The price reflects the mission's difficulty and its scientific importance. This is our chance to answer one of humanity's oldest questions. The stakes couldn't be higher. Bringing samples back from Mars demands strict planetary protection. First, we must avoid contaminating Mars with Earth microbes, so spacecraft are sterilized before launch. Second, we must protect Earth from any potential Martian life. The samples are sealed in multiple layers of containment, breaking the chain of contact. The entry vehicle is designed to survive impact and remain sealed. Once recovered, it goes straight to a Biosafety Level 4 lab, the highest containment. Scientists use robotic arms and glove boxes to handle the material, never exposing it to Earth. Only after rigorous testing will samples be shared for wider study. Planetary protection ensures we explore responsibly and safely. Imagine the moment. A scientist sees a fossilized Martian microbe under the microscope. The discovery of life beyond Earth would be one of humanity's most profound moments. It would suggest life is common in the universe, sparking a new era of exploration. But if the samples are sterile, that's just as important. It means life is rare, and Earth is even more precious. Either result will reshape our understanding of our place in the cosmos. We'll ask new questions about life's origins and uniqueness. Both outcomes are equally staggering. The quest to bring Mars to Earth is a deeply human endeavor, driven by our curiosity and spirit of exploration. For centuries we have looked up at the red planet and wondered what secrets it holds, dreaming of the day we might touch its surface or hold a piece of it in our hands. This mission is the next step in a journey that began with our earliest stargazers, a testament to our relentless desire to understand the universe and our place within it. The Mars Sample Return mission is a global collaboration, uniting thousands in pursuit of a common goal. Scientists, engineers, and dreamers from every corner of the world are working side by side, sharing knowledge and resources. This unprecedented partnership shows what humanity can achieve when we come together, transcending borders and differences for the sake of discovery. Building robots, launching rockets, and returning Martian rocks, these are achievements that inspire generations. Each step forward is a triumph of creativity and perseverance, a blend of imagination and technical mastery. The challenges are immense, but so is our determination to overcome them, fueled by the hope of uncovering something truly extraordinary. The answers hidden in these samples could reshape our cosmic story. Within each grain of Martian dust lies the potential to reveal the history of another world, its climate, its geology, and perhaps even signs of ancient life. These discoveries could change how we see ourselves and our planet, offering new perspectives on the origins of life and the possibilities that await us beyond Earth. Mars offers us a second data point, helping us understand why Earth thrived while Mars became barren. By comparing the two worlds, we can learn more about planetary evolution, climate change, and the delicate balance that makes life possible. These insights are not just scientific, they are essential for the future of our own world. This mission is a leap of hope, uniting us as inhabitants of a small blue dot. It reminds us that despite our differences, we share a common home and a shared destiny. The pursuit of knowledge brings us together, inspiring cooperation and compassion on a global scale. Whether we find ancient life or not, the journey itself will change us. The act of reaching out, of daring to explore, transforms our understanding and ignites our imagination. Every discovery, big or small, adds a new chapter to the story of humanity's quest for meaning. It will push technology, expand knowledge, and inspire new questions. The innovations born from this mission will ripple outward, shaping the future of science, engineering, and even daily life on Earth. Each breakthrough opens doors to new possibilities, fueling the dreams of future explorers. We stand at the edge of a new chapter in exploration, ready to read a story written in Martian stone. The pages ahead are blank, waiting to be filled with discoveries, challenges, and triumphs that will echo through generations. And that story belongs to all of us, a testament to what we can achieve when we dream together, reach beyond our limits, and embrace the unknown with open hearts and minds.